wanted to tell you about Scala Native, give a small introduction, what it is, and yeah, why it might be useful. So, Scala is a language, programming language on the Java virtual machine, and usually it runs only on the Java virtual machine. Scala Native is the project which compiles the language to machine code. It does so by using LLVM. So it takes the Scala code, runs in the Scala compiler as a plugin, and emits LL files, which then LLVM can compile down to machine code. For example, for x86 or ARM or so. So it's a completely new target for the language. The project is rather new. It's being developed by the EPFL in Switzerland. They released in May 2006, this year, a preview with a partial implementation of the Java development kit. So you need to bridge a few things, so you can't take the whole JDK code also because of copyright and so on. Okay. But it works. It's a collection of modules. So you have user space and the compiler space. The user space consists of 3 modules. One is JavaLib, which represents the JDK. The ScalaLib is the Scala language, collections, for example, or I/O. And NativeLib has special data types for low-level primitives, for example, to allocate memory on the machine. Yeah, then there are the compiler plugins and tools. It's all being developed, so it might be the case that things change in weeks or months, but that's the current state. This is how the compilation works. So, yeah, basically it goes from Scala source to an intermediate representation first, and then it goes to LL. And after that goes to object code, which is then compiled and linked to machine code. That's how it Hello World example looks. So it's quite standard. The difference is that you can use now stdio, fprintf, and stdr, and you can use C strings, which you prefix with a C, a small c in front. And this is how you run it from a build environment. Yeah, it just prints hello world. It's nothing special here. If you inspect the output, you see it's an executable for Linux for laptop. Okay, let's take a look at the few additional things. Since you run on the machine, on the hardware, you can do things which you can't do on the JVM that easily, which is trivial from C, but not on JVM yet. One thing are C strings. For example, you can create a hello hexagreen string and print it, select it from the 6th position, so you can give an offset of it. And then it would print hello 5th hexagreen. Then you can allocate memory using malloc, which returns a pointer. So and you can also work with offsets from the pointer. Choose to this is an array of 3 integers, cint, and you can update all elements of that array on their own. What they also added in the project were structs. this is a struct which has one field, which is n, an integer, and two methods. This struct you can then allocate on the stack. This is on the right, the stack alloc. Dereference it and assign a value, which is the new pi 42. And then later use the pointer. Okay, so those were the low-level primitives. Since it should transparently compile Scala, you should also be able to use the standard library. This partially works. For example, in this example, I want to download a URL using the IO source class. When I compile it and run it, it fails since a few types are missing here. Yeah. So one way would be to implement those types and provide a pull request. So it's still a work in progress and people are happy if someone contributes. Or we can just use something like libcurl. This is what the bindings do. That's a build file where you define how the build works and the dependencies and so, and you just add a dependency for LLVM so that it links libcurl to the binary. Then you can write bindings in Scala code to the C library. Those are the curl easy functions. They are thought to be easy abstractions for common tasks. For example, init, clean up, set opt, you can set options. There are a few constants. And this is basically one way to download a file with a missing type using libcurl. So in essence, you can bind to external libraries. Then another example, that's actually the last part of the talk. I wanted to show a bit how to write a program in Scala. And as an example, let's imagine we have a device which has two states, power and GPIO. And the device is represented as a data structure. And we can somehow modify the device. So those are the types. There's type hardware, which represents the hardware device. The GPIO is the state of the I/O module. There are 4 pins, like pin 1, 2, 3, and 4. And one pin can either be on or off. Then the device also has a power state, which can either be powered or unpowered. And a vendor string. So if we want to switch a pin from off to on, we can just write the function which takes in hardware, a value of type hardware, and returns a new value. And additionally to the new hardware, we also are able to return an additional return value. So we return 2 values from the function. So this is a function from type hardware to hardware and sum A. And now in order to switch GPIO's pins on and off or turn a device on and off, we can write small functions. The first one, switch on, modifies the hardware and sets the power state to powered. So it returns a new value of the type. There are 2 functions more. which basically first, in the middle, it returns the state of the first GPIO pin, and the second is a knob in operation. So atomic building blocks of a program. And we can put those blocks together to a larger program. For example, set the pins 2 and 4 to on, delay for 1000 milliseconds, and return the values of the GPIO pins. So we need to switch the device on, and can reduce the larger program in even larger program. So it's composition of functions. And then last run the program. Here you see the output. It's on for pins 2 and pin 4, and yeah, the power state is on the old value, unpowered. On the new value, it's powered. So yeah, just an example for a non-trivial Scala program which is compiled by Scala Native also, and it runs. So, yeah, in the future, they plan to add missing parts of the JDK. For example, regular expressions are missing currently, which is a bit annoying. It should run stable on different target architectures. And one issue is that libraries are currently are not published with the intermediate representation, and they plan to add those files to the published package on Maven, for example. Yeah, so in the end you are now able to compile the Scala language to different targets like JVM, JavaScript in the browser, and to machine code. Okay, that's it. Any questions so far?
I know this was probably not the goal, but have you tried benchmarking it? Okay. Have you tried benchmarking the result of Scala natives with a comparable program in Scala?
I didn't, but the author of the library did. He compared a ray tracer application written in C, in Java, on JVM, and using Scala Native. And yeah, you can watch the talk. He gave a talk like 1 month ago. I can maybe post the link just in the wiki. So, and the result is that it's comparable to C, like 1 second difference, and the JDK example is by larger margin off. So, but there's room for improvement, definitely. Also, you lose the benefits of the JDK. For example, there is no JIT, no JIT optimization.
Why don't they just use the OpenJDK?
Does OpenJDK compile to native code?
I think the OpenJDK is written mostly in Java, isn't it?
Yeah, but then you still would need a JDK to run the program.
No, I mean, the JDK is just like it's the standard library, right?
Ah, you mean
So
because of the missing
part
part?
the OpenJDK is already there instead of writing it all over again.
For example, for I/O, I think you need to use stdio and the C libraries. That might be one reason, maybe another copyrights, I'm not sure. So, but it should be possible to take large parts of the amount of code and just copy them over. That should be possible, I think, in theory. Yeah.
I just hope it's not just some licensing bullshit.
Yeah.
Because it's really sad.
There was once the case with Oracle sued Google about a sorting algorithm, and yeah, things are tricky in that land. But maybe just ask on the forums, and they might have a better answer. Any further questions? Okay.